Welcome to this class on statistics for data science. And today we'll be talking about the most important topics that you need to know in statistics in order to be able to progress in your journey in data science. Now, as you know, statistics is a fairly detailed topic, and this class will be broken up into two parts. First part today will be descriptive statistics, and I'll walk you through that. We'll hopefully reach a little further into descriptive statistics today. And the next piece is what we call inferential statistics, which will come a little bit later, right? Okay, and thanks, Mohammed, for your message as well. Good to see you as well. Thank you. All right, so we all know the three different types of analytics, which is descriptive, predictive, and prescriptive analytics. Now, the statistical part of analytics covers both descriptive analytics as well as predictive analytics. And then what you have after that is really the prescriptive part, which is more the machine learning algorithms, such as the gradient descent algorithm. So let's talk about some of the aspects of statistics that are useful in descriptive statistics. Now, descriptive analytics actually derives itself from the word descriptive statistics, right? And if you understand, predictive analytics also comes from inferential statistics. So as you can see, the pyramid, right, the whole basis for the data science is statistics, which has been around for a pretty long time. Okay, and let's learn about statistics today. The two kinds of statistics that we need to cover in the next few classes is descriptive as well as inferential statistics. Now, if you think about the difference, really, descriptive statistics is about describing what is going on in a particular data and what kind of behavior are the numbers showing. And in inferential statistics is about knowing, can we infer anything from a sample of data that applies to the larger population? And we'll come to this concept in a very short while, right? So think of this as the larger population of a country. And then if you could pull out of this, a smaller data set, right? And suppose you learn things about this smaller data set, and let's call this here the sample, and let's call this here the population. If I want to understand what's going on with the whole population, let's take, for example, exit polls, right? From the sample, okay, of voters who have voted for a particular leader, right? The way you would do that is by using inferential statistics. So you now know that all of your exit polls that happen in countries across the world, whether it's about them Democrats versus the Republicans, or whether it's about the BJP versus the Congress in India, it's all by using inferential statistics. Such is the importance of this topic. Now, some of you will ask me, why do we need to understand statistics in this world where we have a big data, right? And it would be a fair question. And let me answer this question in the following way, right? The size of the data that you work on is not something that you control. So data may be big, but it may also be very small, right? Let's take an example. Suppose you're working in the healthcare industry. In the healthcare industry, you need permissions in order to test a drug on an animal, okay? And there's a lot of groups that talk about animal welfare, and they want to make sure that the minimum amount of animals, are subjected to tests. And how do you ensure that this happens? The only way that you're going to make this happen is by using a small sample size. Now, the moment you use a small sample size, and I'm going to give you some examples here today of global pharmaceutical companies, they actually have a sample size sometimes of just 40 rabbits, okay, or 40 rats. At best, they may get up to 60, right? Rats or rabbits. Now, if you have only 40 to 60 observations, then it becomes really important that you do a great job of your sampling, okay? So how many male and female rabbits should you have in that sample? What should be the age breakup of those rabbits? These are questions that you can only answer if you're strong in statistics. Now, big data is not going to come to your rescue here. It's not even going to help, right? And when you move up from this to human trials, it becomes even more complicated. So for human trials, and let me just put this up over here, you may have very, very few permissions, maybe anywhere between 100 to 150 human beings that you can actually try this drug on. So you can imagine that the total population of the number of beings, if I may use that word, that you tried a particular drug for may be less than 200 beings, right? The only way you get accurate results from that kind of data is by using statistics, and hence the importance of statistics. And I understand that it might be completely different for banking transactions. What are the different kinds of statistics that you need to know in order to be able to master data science, right? And here are the different kinds of statistics. We need to understand the different types of data and variables, the types of variables in the world of data analytics. What is population and sample, and what are the different types of analysis that you can do. We need to then get into measures of central tendency and spread of the data. How spread out is your data? What are the central measures of tendency for that data? And how do you summarize this and understand a lot of data in a single view, right? And what are the ways to do that? Now, all of this together is descriptive statistics. And then we get into inferential statistics, which relies a lot on probabilities. Now, if some of you do not know math that much, do not worry. You know, the math can be learned. It's not so hard. At least all of you do know that if you toss a coin, you've got 50% chances of a heads and you've got 50% chances of a tails. And if you know that much, you're okay, all right? You can learn what we want to teach you in this course. What is a basic ingredient for any analysis? Let me ask all of you that question. In order to do any analysis, what do you need? Okay, so you need to answer in the chat box. Absolutely. So Vismita says data and Howard says a data set, right? Okay. And the difference between those two words is that the data may actually be unstructured. And when you get some structure to it, what you get is a data set. So thank you, Vismita and Howard, for your responses. For those of you that are new to our webinars, we have a very, very interactive webinar. So please do make sure, Andy, Gaurav, Joanne, Jyoti, that you all, Mohammed Iman, Parthi, please jump in and share responses, right? The best response is any response. It's not about right or wrong. All right, so I'll open up quickly, a data set. Let's open up what you need for any analysis. What you need for any analysis is data. And here's some data. Here we go. So we've got, cars. And these cars are from countries of different origins. And as you can see, some of them are American, some of them are European. You've got some cars that are actually Japanese, right? So, and then you also see the model of the car, and these are old cars. So you see the Buick, you see the Chevrolet Impala, the Ford. Some of you are going down memory lane with these cars. You see the miles per gallon, the average mileage that you get from these cars, along with how many cylinders they have, how much is the engine displacement, horsepower, weight, acceleration, and year. And this describes a lot of cars. So if I just sort of, say control shift down, I see that there's 393. Okay, and the shortcut I used is control shift on my keyboard and the down arrow key. So 393 cars, okay, minus one, 392, because you've got one row. This describes cars, but can you tell me anything else about these cars except for, the miles per gallon, cylinders, horsepower, weight, acceleration? Do we see any other insight at this point in this data? Yes or no? Is there any insight that you see, guys? That's all. All I want to see is a yes or a no. Please vote. Or do you just see raw data at this point? Okay, no, absolutely. Thanks, Howard. And you're right, right? You're right. And thank you, Puga. So you're absolutely right. All you see here is raw data. Thanks a lot, Vismita. All right. So, you do have raw data here, and that's what you just saw. And this is a definition. I'll spare you reading this particular definition outside, but it's just unprocessed data, right? It's just a collection of some numbers. There's some characters like Japanese, American, and, but it's not beyond that. How do you move then beyond this point and move beyond this tabular data that we just got right now to something a little more meaningful? We know that it's describing cars, but it's not conveying anything else at this point, right? The way we'll do that is we'll do a very simple operation, which a lot of you already know. We'll insert a table. So I'll just quickly insert a table. If you don't know how to do this, please click anywhere on your data, and after clicking, do a Control A, Control T, and after Control A, Control T, just check box my table has headers, right? And you get a, a table here, right? Okay, so after you insert the table, I'm actually going to go and insert a pivot here very quickly, yeah? All right, there we go. Now, once I've inserted this pivot, we're going to have a look at, what insight we can draw from the pivot or from the data, okay? Just give me a second here while I get this going. Okay. I think Excel here is misbehaving. Just give me a second while I'll resolve this. So my question here is that when you look at this pivot, and I'll just repeat the question, you've got miles per gallon, you've got the make of the cars. Which one is the most fuel economical car that you see here? Is it American? You can punch A into the chat box. Is it European or is it Japanese? And I'll wait for your responses. So clearly the Japanese cars are giving you more miles per gallon than any other car out there, isn't it? Now, what you're moving to now is you're moving beyond just the raw data, right? So what just happened is we moved beyond the raw data to some information, some meaningful information, right? And this is the process that you follow in analytics. You move from raw data to information, but you do not stop at that point. You move further on inwards in your journey and you try to derive some knowledge, okay? So what I'm going to do is I'm going to add something more to this pivot. Apart from the origin of the car and the miles per gallon, I'm also going to throw in some cylinders, okay? So let me add horsepowers. In fact, instead of, cylinders, let me throw in some horsepower here. So just give me a second here. I'll just again work my pivot, right? And throw in the horsepower. Now, the moment I throw in the horsepower, what you see here is the American cars on an average have a horsepower of 119. You've got European cars with 80.6. You've got Japanese cars with 79. So do you all now notice that the Japanese cars have the least power, but the maximum mileage, right? And you all also see that the American cars tend to be really big on power. Okay, they like that over there, but a little lower on mileage, right? Do you see this additional information about the origin of the cars and the mileage? And do you also see a relationship between horsepower and mileage? So can someone tell me what relationship do you see between mileage and horsepower while I just create my pivot again? Okay, I'll just wait for your responses. Do you guys see any relationship between horsepower and mileage? Absolutely. So I'll just take miles per gallon over here and I'll take horsepower over here. I've got Excel up again and I'm going to add to this the origin over here. There we go. And just move to the average horsepower. There you go. Okay. Right. So as we do this, what you'll notice is absolutely right that these are inversely proportional to each other, isn't it? Okay. So what just happened right now? You learned that American cars have more horsepower, Japanese cars are fuel efficient, but you also learned that horsepower as a variable is inversely proportional to mileage, which is another variable. Now, what you call a column, okay, in Excel is actually a variable in the world of analytics, all right? So these are columns in your Excel sheet, but in the world of analytics, we refer to these as variables. All right, so I'll just go back here to me Excel, right? And I'll delete this. And so you all notice the types of variables, many different types of variables that you have over here in this data. We're going to learn what are the different types of data variables. So for a quick second, I'll just, get the origin and the cars back again. Okay, there we go. Miles per gallon, go for the average miles per gallon. All right, there you go. And add to that perhaps the horsepower, which we had a short while ago, right? So, all right, fantastic. Okay, so I'm going to go back to presentation here. What we just learned is we moved from information to knowledge. So when you learn relationships, and I'll just put this up on the board there, right? We learned about a relationship between horsepower and mileage. And that relationship is actually moving up from, information to knowledge. Okay, and these are simplistic, and we'll of course get into many more details. But then now, let me ask you a question. That having looked at this data, right, you know that if a car's horsepower goes up, the mileage, actually goes down, right? So if I use a different color code, you can see that the mileage is going down to a point where a car that has a horsepower of 119 has a mileage of 20 miles per gallon. Let me ask you, if I introduce a new car in the market, and it's probably an American car, but let me not say that, let me just say it is 125 horsepower. Can you predict how much the mileage might likely to be? Do you think it would be probably more than 20 or less than 20? Let's talk about that. So option A, let's say it's more than 20. Option B, it's actually less than 20. Okay. Absolutely. So I've got a bunch of responses there. So you can all see, right, that it's likely to be less than 20. So what's happening now? What's happening, Howard? What's happening, Puga, HP, Vismita? What's Raj? What's beginning to happen is that we're moving beyond just information. Okay, so we're actually moving up to predicting. But you saw that, we never, predicted directly. We didn't look at the trend directly, right, Howard? We moved through the whole process of looking at the knowledge of the cars, understanding that cylinders and miles per gallon are sort of inversely proportional, understanding cars of different countries and how they behave. And then raw data isn't quite ever as clean as this, isn't it? 70% of the time that you spend would be scraping this information off some website using Python or R, and 90% of the time is actually typically in the analytical journey is spent on the bottom three parts of the pyramid. And surprisingly, the predictive analytics, which is the coolest part, is probably just 10%, okay, of the time that you do in the industry when you actually work on data in the industry. That's just probably 10% of your time. So this is known as the analytical pyramid, for lack of a better word. It's how you actually work in sequence on a project and take it to fruition. But we need to learn a lot of things, okay? And let's start with population and sample. Just want to give you a quick idea about this. You see, if you want to know the height of all the women in the US, okay? Let me just quickly ask you a question. Okay, in the US, there you go. That's your problem statement. You want to know the height of all the women in the US. Do you think it's possible, and I'm just looking for a yes or a no, do you think it's possible to survey all the women in the US and figure out what their height is and then come to an average? Yes or no? It is not, right? So why is it not possible, guys? Rajshekhar, Howard, why is it not possible? What are the reasons for which you cannot always get all the data? Nice and easy. Come on, everyone can take a guess here, right? It's very easy, right? Okay, too many variables, or yes, absolutely. So too many observations. We would just call that an observation. The height of every lady will be known as an observation, right? So one is that. What other challenges can we have in trying to survey all of the women in the US? Come on, guys, this is common sense, yeah? Joanne, Mark, Mohammed Iman, Shinat, right? You guys, this is all common sense. You can do it. Okay, Ashish, Andy. Right. So guys, think about this, right? Okay. What about the cost? Do you think it's going to cost a lot? And then do you think the data is dynamic. So as you actually interview people and try to reach out to all the women in the US, you might find a lot of them were born and a lot of them unfortunately, moved to a different world, right? So the data is dynamic, there's a high cost. Yeah, absolutely. Right? So this is not practical. Net, what we're saying is this is not practical. So what do? What you do is you take a sample, okay? But taking that sample, there's a method to that madness. Okay, so let's take, for example, if you say that 15% of the women in the US are greater than 60 years of age, or I'm sorry, let me just change this a little bit. Let's say 45% of the women in the US are actually greater than 60 years of age, and then let's say the rest of them, okay, which would be around 55%, are actually less than 60 years of age. Okay, if I decide to sample some of the women in the US, and let's say I decide to sample 200 women across the US, okay, and I'm just taking a simplistic example here, I would need to make sure that a certain number of them are older than 60 and a certain number of them are younger than 60 years of age. Can someone tell me how many of them ought to be greater than 60 and how many of them ought to be less than 60 years of age? Come on, guys, pretty easy, won't be so hard. Okay. Right. So there you go. We've got some responses already. So let's put it like this, right? So Mohammed Imam, the way you want to look at this is, and 100 each. See, so that's a great answer. Okay, so I like that answer. Let me just take that for a minute. So Mohammed Imam says, let's go with 100 people, 100 women older than 60 and 100 women lesser than 60. Does anyone have a different opinion? Does anyone think we should take something different? And just say yes if you think that there's a different answer. I don't need the answer. I just need a yes or a no. Everyone, please give it a shot. No, okay. How about that? Yes is Howard, okay. All right. So guys, the answer is that it should be a little different from the answer that was shared a little earlier. You see, if you've got 200 women and you know that 45% of all the women are more than 60 years of age, you've just got to make sure that this sample is representative. And I'm just using the word representative. Here we go. Of the population. Okay. There we go. Let's just understand this word representative a little bit better. Okay. For it to be representative, the breakup of women who are older and younger than 60 years of age in this sample of 200 women should be same as for the overall women in the US population. So if you take an example here, if 45% of all the women in the US are greater than 60 years of age, we need to make sure that 45% of the women that we are going to survey are also greater than 60 years of age. So can someone tell me, what is actually 45% of 200? Anyone? Nice and easy, isn't it? There you go. So the answer is 90. Now all of you understand, right? So I'm just going to make this 90. And if I have 200 women that I'm serving and 90 of them are going to be greater than 60 years of age, how many of them are going to be less than 60 years of age? Absolutely, right? So 110. There you go. And so you now know, you have an idea of what is a sample. You have also understood what is a representative sample. Okay. And what we did was we took a sample and then we ensured that it is representative. And thanks a lot, Raj, Puga, and Howard. We ensured that it is representative by making sure that the breakup in the sample is the same as the breakup of the US population. There you go. All right, so that's the concept of population and sample. Now we're going to learn about three kinds of analysis, which is univariate, bivariate, multivariate, and we're going to learn about the different kinds of data variables. Now we just learned a very short while ago that in any analysis, right, all of these column names that you see here, like miles per gallon or cylinders, horsepower, these are all variables. So in the world of data science and analytics, we call these variables. Let me just insert a row here and let me just merge all of these together and type here variables. There you go. Okay. Now let me ask you a question. How many variables do you see here? Now this is really easy, okay? So I'm looking for everyone to answer. How many variables do you actually see right here? Which is equal to the number of columns. So A, B, C, D, E, F, G, H, I. There you go. So we see 9 variables, right? Fantastic. Okay, and when you actually get to analyze these 9 variables, you'll understand what is a univariate, a bivariate, and a multivariate analysis. Okay, so I'm going to insert a pivot again, and I'm going to ask you a question. A univariate analysis is nothing but when you have only one variable that you're going to analyze. And a bivariate analysis is when you analyze two variables or two columns together, all right? And you look for a relationship between those two columns. And then a multivariate is actually when you do more than two, so greater than two variables, and you analyze them together. That would be a multivariate analysis. Now, armed with this information, we're just going to quickly, create a pivot again. So let's look at the origin of the cars and put in a miles per gallon. Okay. Now, can someone tell me when I try to look at the origin of the cars and the miles per gallon, and I'll convert this again to the average, right? I'm trying to see, what is the average miles per gallon for cars of different origin? What kind of analysis is this? Is this a univariate? So you can put a U, a bivariate, a B, or a multivariate, and M. Okay, so I'm going to get your responses very quickly, yeah, and move on from there. I'll just make the number of decimals a little lesser there. Okay, so some of you said univariate and one of you said bivariate. Let's ask Howard the question, why did he think bivariate, right? Because a lot of people answered univariate. Okay, so Howard, we've got miles per gallon. What else did you see there? And Joanne also thinks bivariate, right? So Joanne and Howard, what are the two variables you see there on the screen? So one is miles per gallon, but there's another one that you see which led you to say that this is a bivariate analysis. So which one is it? Let's go back to the car sheet. The country of origin, right? And Muhammad Iman says more than one. Joanne says the country of origin. Howard says type and MPG, isn't it? So let's go back to the data, guys. Now we all need to clap for Joanne and Howard. Okay. So I'm going to type in a clap in the chat box. There you go. Right. And all of you need to be nice and you need to type a clap. Okay. What typically happens is, we look at this whole analysis and we believe that numbers are the only variables. Okay. And it's just a human thing, right? We think numbers are variables. So we all think that there's only one variable in here, which is the miles per gallon. And the moment we think it's only one variable, we believe that this is a univariate analysis. And those of you who answered univariate, thank you for making that mistake. Okay. A lot of people make that mistake. The other variable is also the country of origin. Okay. And it's not exactly country because, when you look at that variable, you realize there's Japanese American and then there's European. Europe is not a country. It's probably more, it's a variable that's just origin. Okay. So you've probably got two variables. So it is not actually a univariate analysis. It's actually a bivariate analysis, isn't it? You're trying to look at MPG and the country of origin, right? Okay, so those of you who answered correctly there, thanks a ton. Now, suppose you had to add one more variable, right? Horsepower. Right? Now I've got horsepower added as a variable here. Okay, I could add it in the filter. I could add it in the columns. I could add it anywhere, right? That doesn't really matter. Now that I've added horsepower, okay, I start seeing the horsepower of American cars and the miles per gallon. I start seeing three things together. Okay. So can someone tell me that the moment I add horsepower, I've actually got how many variables now here? I've got horsepower, I've got origin, and I've got miles per gallon. So what kind of analysis are we doing now? Is it univariate? Is it bivariate? Is it multivariate? It is multivariate, isn't it? So Joanne, you could call it trivariate analysis. But the best way to think about it would be multivariate because we typically don't use the words trivariate or quadravariate or pentavariate. We just go with the word multivariate, right, to keep things simple. Okay. There you go. So you have now all understood. Are you super clear on what is a univariate, bivariate, and multivariate analysis? Please say yes in the chat box. Just say a Y, and thanks, Howard, for that response. Okay, superb. So we now need to understand the different types of data variables. Let's move ahead. You've got numerical variables and you've got categorical variables, right? We'll understand what are those. And then within numerical, you've got continuous and discrete variables, and within categorical, you've got ordinal and nominal variables. So let's actually understand these four different types of variables. I'll quickly cover them in terms of the theory. See, a continuous variable is numeric, so is a discrete, while ordinal and nominal variables are, you know, categorical variables. Let's first understand what is a numeric variable. Okay, so I'll go back a couple of slides. Kaboom, here we go. Yeah, here we go. So see, it's just got to fulfill a few criteria. Okay, criteria number one is that it has to be a number. So it's simple. And criteria number two is that it has to be meaningful to use an operator. So if you want to use a math operator, a mathematical operator, there has to be a meaning to doing it. Okay. If it fulfills these two criteria, and these are the only two criteria it needs to fulfill in order to be called a numerical variable. Let's understand, and let me just quickly, give you a couple of examples. The first example is, I'm going to talk about the weight of some objects. So you've got the first object, the weight is 42 pounds, okay? And you've got the second object, the weight is 30 pounds, right? Okay, there you go. Now, can someone tell me that what is the weight of the two objects combined? In the chat box, please. What is the combined weight of these two objects, 42 and 30 pounds? Absolutely, right? 72 pounds. So would you all be confident in saying that it looks like weight as a variable fulfills both the criteria? It is a number and it is also meaningful to add it, right? So you can use a mathematical operator, which in this case was plus. You added 42 plus 30 and you came to the number 72. So would it be fair to say that the weight is a numeric variable? Yes? No? Absolutely, right? It is. It's fair to say. Okay. Example number two. Let's talk about the rank of two students in the class. So you've got Pete and you've got Jose. Okay. So Pete stood fourth in the class. Okay. And Jose, he stood ninth in the class. Now, would it be fair to say that when you combine these two and use a mathematical operator, would it be meaningful to say that together Pete plus Jose stood 11th in the class? It is not meaningful, isn't it? It is not meaningful. All right, let me take another example. I just want this to be crystal clear in your heads, guys, okay? So we're going to take the examples of employee IDs, all right? Now, these are also numbers. So let's say, Pete and Jose, they both work in HP, and Pete's employee ID is 34553345. Well, Jose's ID, he joined a long time ago. He's been around for a very long time, and that's his ID there. Okay. So would it be meaningful to combine them and use a mathematical operator and then say that together, and someone can do the math on me for this, yeah? Nice and easy, isn't it? So it's 33455 plus 12695, and combined with the employee ID together be 46150? It would not, right? So thanks a lot. Okay, so you know what's happening, guys? All of you are very clear on this. You see, any number is not a numeric variable, okay? So just any number, just because it's a number in the world of analytics and data science, it does not mean it is a numeric variable. It needs to also fulfill the second criteria. And as you can all see, rank in a class, okay, or employee ID, they fulfill the first criteria. Sure, they're a number, but they do not fulfill the second criteria. It's not meaningful to use mathematical operators. Now, it's not just about addition, okay? There's no point subtracting, there's no point dividing, and there's no point multiplying ranks or employee IDs, isn't it? Right? So you'd all agree that it's not just about addition. I can actually run any mathematical operator on this. There you go, kaboom. So you've all understood now what is a numeric variable, okay? Now that's the easy part. Now, after this, the ones that are numeric and they have decimals, all right, those are known as continuous, because my weight, if you take an example, it could be 72.5, but you could continue, and that's why we call it a continuous variable. It could be 72.6, it could be 72.7, right? So it is continuous. Okay, it could even be 72.55. It can just continue on, right? And you call that a continuous variable. It has a decimal in it. Okay, so a numerical variable which fulfills both of those criteria and can have decimals is known as a continuous variable. But if it cannot have decimals, it is known as a discrete numerical variable. Let's take an example, okay? So how many cars could I have? The number of cars that I can own, right? Let's take an example of that. Is it possible to own 2.5 cars? Anyone? Is this senseless, isn't it? Right? It's senseless. It is not possible. Now, as a matter of a joke, if your wife is sharing your car with you, if your spouse is sharing your car with you, or if your daughter takes the car away half the day, you might actually end up using the car 2.5 times as much as you'd want to if you've got 3 cars. But that's a joke. Jokes aside, the number of cars that you own cannot have a decimal. It's just not possible. So it could only be 1, it could be 2, it could be 3. All right, the number of hands that I have, it could be 2, it could be less. Let's not get there. But what I'm saying is that you cannot have decimals. So no decimals is a discrete variable. Are you guys now completely clear about a continuous variable? All right, and are you clear about a discrete numerical variable? Okay, that's great. I think we're making good progress, aren't we? We're learning about the different kind of variables in this world of data science, and all of this is going to be really useful when we work our advanced analytics and when we move on in the accelerator. Thanks a lot, Joanne and Puka. Good. So it's time to now understand what is a categorical variable. Okay. So if condition number 1 is not met, and you remember condition number 1, isn't it, that it should be a number. Okay. Now, if that condition is not met in a numeric variable, automatically it becomes a categorical variable, right? So all of those examples I gave you, right, those all become categorical variables if they're not numerical variables. Let's start with the fact that you could, have any data, right? Any data. Let's say, for example, my name is also a variable in the world of analytics. Now, my country is also a variable, which country I belong to, and you all saw the country of origin, right? Now, all of these are not numbers, okay? So definitely, one thing that we know for a fact is that if it is not a number, then it is definitely a categorical variable. In some cases, we also know that even if it is a number, for example, the rank in a class, right, it fails the second condition. So even if the rank is 1, 2, or 3, in honesty, it's not 1, it's I stood first, isn't it? So I'm the first employee, in the class. I'm the second in the class. I just chose to write it in a numerical format so that it's easy. but I stood third in the class, or I'm the first employee to join, the second or the third employee to join, isn't it? So all of these, are also categorical variables, even though they're numbers. And then other variables like my name, Jose or Pete, or my country, France, New Zealand, or Australia, all of those are categorical, variables. The question then is, what is an ordinal categorical variable, and what is a nominal categorical variable? In order to learn this, we need to go back to our English. So let's just pick out these two words here, and I go back to my little scribbly board here. There we go. And I'm just going to type this out for you. Give me a second here. Right, so nominal. And I'll just a couple of enters and ordinal. There we go. Let's start with nominal. So you often hear that, there was a burglary, but the amount of money stolen was nominal, or there's a nominal amount of articles that were stolen, or a nominal amount of money was lost in a bank transaction. What is this word nominal? It basically means a very little. All right, so if I just put this in this way, it means a very little. Nominal, it means little because a very nominal amount of information is being conveyed by that variable. Let's take a couple of examples here, to cement this thought in our minds, right? Okay, are the area codes or country codes considered a categorical variable? So absolutely, that's a great question there. So Howard, has a question. So if you've got zip codes, let's say 226601, and you've got another zip code for a different area, let's say 227713, would it be, and let's say that the first area is called area A, and the second area, I mean, let me just play around with this here, right? Let me just call this Austin for a second, right? And let me just call this, here, let's just take any other county. Let's take Knox County. There you go. There's a county called Knox County, okay? So if these are the pin codes, would it be meaningful to say that the combined zip code of Austin and Knox together is 226601 plus 227713? Would it be meaningful to say this? If not, okay, then what we learn is that this particular variable, the area codes or the country codes, these are categorical variables. They're not actually numerical variables. Okay. Now, what we need to understand is, since the conditions were not met, they were categorical. What we need to understand is, are they nominal, okay, or are they ordinal? Now, nominal means a small amount of information. So let me just talk about this a little bit here. Okay, let me just take the name, right? And let's say you have a lot of names in your data. You've got Ram, you've got Pete, you've got Jose, you've got Shelly, right? Let's say you've got these 4 names here. You've got Aaron. Okay, you've got these names here, right? Now, can anyone of you tell me that what is the religion that Ram subscribes to? Absolutely. So Howard says no. How about the others? Vismita says no. Why do you guys say no? Sounds like this guy might be Hindu, isn't it? Yeah. And it sounds like these guys down here, Pete here, my friend, he sounds like a Christian, right? Would I be right in saying that? So Puga says Hindu, Vismita says no. So we've got some controversy, right? Joanne says no data yet. Okay, so you guys, you completely, I think, understood what I'm trying to say here, right? For all you know, okay, Ram may have actually converted to Christianity, or in a lot of cases, you have names. Let's take, for example, in India, you've got names like Ram, and then you've got the name of a saint, for example, let's say Saint Thomas. So his full name might actually be Ram Thomas. Okay, there you go. So now your assumption was wrong. It didn't convey that he was Hindu, right? And Pete, what happened to Pete? to Pete. Pete decided somewhere along the way he had a change of heart, right? So, and he decided somewhere along the way that he was deeply, impressed by the Prophet, and so his name is now Pete Muhammad. All right, there you go. Oh, so this is getting a little tricky now, isn't it? So, do you think on the basis of name you can tell me which religion they belong to? Yes or no? Right. Okay. So Howard says, I need the last name variable. Okay. But Howard, even if I give you the last name, it can be tricky. Okay. In a lot of cases, people don't change their name, but they change their religion in official records. There you go, Howard. So you're stuck, aren't you? Yeah. So, Puga, Raj, and Vismita, you're absolutely right. You cannot. Okay. Why do we call this variable a nominal variable? Because it gives you a very small amount of information. It does not give you any information other than that small amount of information. You cannot infer, where Ram lives, which country in the world. You cannot tell me for sure which country Pete lives in or where his ancestors came from. Absolutely nothing. You cannot comment on anything about these people except that their names are Ram and Pete. Whenever a variable is categorical and it gives you only a very small amount of information, nothing more than that information, it is known as a nominal categorical variable. There you go. Then the question is, what is an ordinal categorical variable? And the answer is hidden inside. So nominal is actually small amount of information, and ordinal has the word order inside it, if you notice. Okay, so let's take some examples. All right. And I love examples because they're the best ways to learn. Let's say you've got t-shirt sizes. You've got small, you've got large, you've got extra, extra large, you've got extra large. First of all, can you tell me, is this a nominal variable? Is this a categorical variable, or is this a numerical variable? So C for categorical, N for numerical. Please reply in the chat box. Is this numerical or is this categorical? Okay, so you got it. It is a categorical variable. Now, do you see any order in this? Can you notice any order in this? You all do, isn't it? The moment you notice an order, for example, small, and then large, and then extra large, and then extra, extra large, right? You do see an order. Such a variable is known as an ordinal categorical variable. And if you do not see any order, such as Ram, Pete, Jose, Shelley, Aaron, is any one of them greater than the other? You do not see any order, okay? Then it is a nominal categorical variable. So we've ended that part of the lesson. We just stop here for a second, right? There you go. So you have now understood that if it is not a numeric variable, it's a categorical variable. And you've also understood that numeric variables that have decimals are continuous. The ones that do not have decimals are discrete. Okay. And you've also understood that if there is an order in a categorical variable, it is known as an ordinal categorical variable. It's the ones that have an order. The ones that don't have an order, they're known as a nominal categorical variable because they only convey a very small amount of information. They do not have any order. Okay. Are we good so far? So we've got a question here from Joanne Lambrecht. So is a member subscription like free, premium, or deluxe considered an ordinal variable? Okay, that's a great question there. All right. So if you look at, free, premium, and deluxe, okay? There is an order to this. If you understand this in more detail, the one that's free is probably going to be $0. Okay, the premium one might come with a monthly subscription of $5, but for the deluxe, you may have to pay $15. So there's clearly an order in terms of the amount of money that you might have to pay, isn't it? So one is the dollars. The other is the features that you get. So let's talk about the features for a quick second. Free may have 3 features, premium may have 5 features, and deluxe may actually have 8 features in the product, isn't it, Joanne? Okay, so not only do we notice that there's an order to the dollars that I pay, but we also notice that there's a similar order to the number of features that I get on the product. So what would you say, Joanne, looking at all of this, would you say that this is um, an ordinal variable, free, deluxe, and premium? I'd probably vote yes. Yeah, there you go. This is probably an ordinal variable, isn't it? And how do you know that small, medium, and large t-shirts are ordinal? Because you do see that a small t-shirt, or let's take for example jeans, right? Let's take for example jeans. This may be just 28 inches, right? A medium one might be 35 inches, or let's say 32 inches, in fact. And let's say that a large one may be anywhere which is 35 inches, and let's say that an extra large one would be 38 inches, right? So there are some numbers and there's a clear order. Likewise for memberships, there you go. So it would be an ordinal variable. Have I answered your question, Joanne? Just wait for a response from my friend Joanne there. All right, superb. While Joanne comes back, we have all understood the 4 different types of variables. So let's go back in our presentation to our little journey. And don't you guys worry, I've got a break lined up for you. So we've got a lot of break for tea, coffee, and bio breaks. All of that is going to be there, okay? So just hang around with me, and whenever you feel tired, let me know. Okay, thanks a lot, Joanne. Okay, where are we so far? So here we go. I'll just go back to my first slide. There we go. We've actually covered a significant distance. We've learned about data and variables. We've learned about the types of variables. We've learned about population and sample and the types of data analysis. There's one last type of variable that I want to show you before I move ahead to descriptive statistics and mean, median, and mode. And I'll probably give you a break because all of you deserve a break. Wow, what a great class I have here today. Okay, so we're going to give you a nice break after the next topic that I'm just touching upon, which is a random variable. Okay, so let me just come to random variable now. Give me a second here. There we go. So apart from all of these types of variables, I also want to talk to you about a very important kind of variable called a random variable. You see, probabilities are really important, right? All of these algorithms, starting from Amazon, Google algorithms, all of them have an accuracy, okay? Now, this word here, accuracy, is nothing but a probability. It's a likelihood that the answer that the algorithm is giving you on the number of people that are likely to ask for a ride on Uber on any given day or time can be predicted. And if that number is $1.289 million, I'm sorry, not 1.289 million rides, then it comes with an accuracy of the prediction, and that accuracy could be 92% accuracy. So there are 92% chances that this answer is correct. That is accuracy. But this comes from the concept of probability. You see, there is something called an event, okay? And an event, let's talk about the tossing of a coin. There are 2 possible events or 2 possible outcomes when you toss a coin across the world, right? Okay, so those outcomes for a coin are heads and tails, and those are the 2 possible events that can happen when you toss a coin. But when you roll a dice, can someone tell me how many events can happen? Is it 2 events? Is it 4 events? Or is it 6 events? When you roll one dice, okay, just one dice. Right, there you go. So it is 6 possible events. There you go. Okay. Now, see, the event can also be defined a little differently. For example, if I say I throw 2 dice and I get even numbers on both the dice, right? That is the event. So you could define the event differently as well. I could even define an event saying, if I get 3 on the first dice and 3 on the second dice, then that's my event. There you go. Okay, so let's talk about a random variable. Random variable is a variable which can take multiple values. So it's condition number 1. It needs to be able to take multiple values. And you see that over here. And there is a probability, and if some of you don't like math, okay, don't you get put off by the word probability. Let me just use the word chance, okay? There's a chance associated with each one of these values, okay? Let's talk about tossing of the coin, right? So there is a chance, and it is a defined chance, right? It's not random. We actually know exactly what the chances are. So there's a defined probability for each of the values that it can take. If you meet both of these, criteria, that there are multiple values that can come up in an event, and probability for each one of those values is defined, then that variable is known as a random variable. So let's look at the toss of a coin. We know that the two possible outcomes are heads and tails, right? So how many, values can it take? The toss of a coin? Is it 1? Is it 2? Is it 3? Absolutely right. Guys, there are two values that it can take, isn't it? When you toss a coin. So there are two possible values, heads and tails, right? Value number 1, value number 2. Okay. So multiple values, yes, it can take two values. Now, can someone tell me what are the chances that I'll get a heads? What percentage chances is it? Come on, guys, girls, everyone. What are the chances of a heads? There you go, 50, right? Half, right? Half and half. So 50% chances that I get a heads, and there's also 50% chance that I'll get a tail. Okay, so what you notice is that there are defined values, heads and tails, and there are defined chances, clearly defined chances. 50% that I get heads and 50% that I get tails. So this is a random variable. The outcome of a toss is a random variable because it can take two values. So it can take defined number of values, multiple values, and for each one of those values, there's a clearly defined probability. It's 50%. Okay, if we've understood this well, let's just, go back and go back to our drawing board over here, right? And let's now talk about throwing one dice. Okay, it's time for some artwork. Okay, so you're gonna pardon me, my artwork here. I was never really good at arts. Okay, there we go. So you've got in a dice, you can get a lot of outcomes, right? You could get 1, you could get 2, you could get a 3, right? All of those things are possible. So when you throw this dice, there are two conditions that it needs to meet to be a random variable. One is that there should be multiple values, and the other is for each value, there should be a defined probability. Okay, there we go. Let's see if the tossing of a dice meets these two criteria. All right. So I've got someone drawing on the board there. Thank you so much. I think that was a lot of fun. So I'm just going to put that smiley here. Okay. And focus here now on my questions. Okay. The one who drew, I need to ask you some questions. Okay. Here we go. Can you tell me what are the values that I could get when I throw a dice? How many values could I get? Very good. 1, 2, 3, 4, 5, 6 says Raj. So Raj, how many are those? What's the count? Can someone tell me the count? 6, isn't it? Okay. So I've got 6 values there. I've got 1, 2, 3, 4, 5, and 6. Okay. Now, can someone tell me what are the chances that I'm going to get a 1? What are the chances? How do you calculate those chances? 1 divided by 6. Okay. Now, how many of you are not sure how they came to this answer? So I know Raj, HP, and Howard are clear. Who is not clear about this? Please be honest so I can explain this to you. Just say not clear. Okay, and just say no. So I'll just explain this to you. Otherwise, I'm assuming all of you understand how this happened. Okay, now it looks like all of you understood, right? But just just to make it really clear, I'm looking for one value, and the number of possible values is 6. So if I look for any particular value, let's say I'm looking for a 1 on the dice, okay, or I'm looking for a 2 on the dice, the chances that I'm going to get a 1 are exactly 1 divided by 6. Okay, there you go. So you're all clear on that now, isn't it? Because I'm looking for 1, but you know what might happen? I might end up with 1, 2, 3, 4, 5, 6. Okay, so my chances are 1 divided by 6. When I toss a coin though, I'm looking for a heads, but I can only have 2 possible outcomes. It's 1 divided by 2, so it's 50%. Can someone do the math and tell me how much is 1 divided by 6 in terms of percentages? Yeah, it's around 16.6667%. Okay, there you go. Okay, so you're all now clear on what is a random variable, right? And let's now say that 2 of us in this audience decide to have a little toss, all right? And I'm just going to pick 2 people here randomly. Let's say Mark and Jyoti decide to have a toss. So Mark says, if I get a 4 on the dice, then I'm going to, take $10 from Jyoti, so I get richer by $10, okay? And the other person in this game is Jyoti, and she says, well, Mark, if you're not going to get 4, if any other number comes apart from 4, then guess what's going to happen to you, Mark? You're going to pay me $10, so it's negative $10 for Mark, right? And let's say, for example, that Mark's payout is the variable. Okay, there we go. So this is the variable. I'm just going to ask you a couple of questions to make your concepts very clear. If the variable's short form is MP, Mark's payout, as a result of this game, first of all, tell me, is this a numeric variable or is this a categorical variable, Mark's payout? So say N for numeric and say C for categorical. Superb. Okay, so it is actually a numerical variable, okay? It's a number, right? And you could, if Mark does many tosses, you could even find out and add those tosses. So let's say they play 3 times, right, Mark and Jyoti, and the first time Mark gets 10, the second time Mark gets 10, but the third time Mark loses 10. So all in all, it would be possible to add all of these and say that, Mark, he made $10 out of the game, isn't it? So you can add it, right? So it is a numeric variable. It's not a categorical variable. But the question is it a random variable? So it needs to fulfill 2 criteria. The first criteria is that it should take Mark's payout should take defined values, right? And the second criteria is that for each of those values, you should have a defined probability. Now in this little game here, it is, a random variable. Yes? Okay? So you've all answered correctly for the reason that there are only 2 possible values that it can take. The first value is plus 10, the second value is minus 10. The chances of it taking plus 10, okay, are, so Mark needs to get a 4 on the dice. So 4 is one particular outcome or one event on that throw of a dice. But how many events are possible? 6 events are possible, right? So 1 upon 6, which is 16.66%, are the chances that Mark's going to make money And that's why Jyoti decides that she's going to jump in and she's going to play the game with Mark because her chances are pretty cool. They're actually 5 upon 6. There are 5 events that are possible where Jyoti will win. Let's talk about those events. So on the dice, if you get 1, if you get 2, if you get 3, if you get 5, or if you get 6, then Jyoti wins. So she's very happy because there are 5 possible, you know, events where she's going to win out of 6 total events. The only event where she loses is if, if it's a 4. Now, given this, she agrees to play the game. Now, Mark's a gambler, so he tries his luck. Okay, there you go. So this variable, Mark's payout, is also a random variable because it can take 2 defined values, plus 10 or minus 10, and each one of those values has an associated probability. 16.66%, and the other one is actually 100 minus 16, which is 83.333%, is the probability that Mark's going to lose. Okay, those are the 2 defined probabilities that this variable takes. Okay, there you go. So I hope we're now clear. Thanks a lot, Raj, for your response. Okay, so let me just check with everyone. Is everyone very clear with what is a random variable? Anyone who has a doubt? All right, that's great. You guys are clear. That's great. So what we'll do now, folks, is we'll take a break. All right. So typically we take a break of around, let's say, 15 to 18 minutes, right, to get our coffees and take a quick bio break. Okay. So let me do a countdown timer. You guys can vote. Okay. I'll just do a countdown timer here. All right. Are you guys okay with let's say around 16 minutes? Is that okay? Works with everyone? Yeah. So Raj, once we come back, we won't be continuing for too long. I just need to cover mean, median, and mode. Okay, Raj. So perhaps just around 1 hour more for today. Okay. So Raj, I hope 16 minutes is okay. There we go. Thanks a ton, folks. See you in 16 minutes. Folks, welcome back from the break. And before we go anywhere else, I just want to make sure that all of you receive the recording for this class. Okay, so I'm going to share a quick feedback form. And I've got all of you guys here, of course. So please do just fill up this feedback form. So I make sure I send the recording, the presentation, and the data. And I'll wait for all of you to confirm. So Raj, please click on this particular feedback form that I've just sent in the chat box. It's nice and easy. Just a couple of questions. That's about it. Just 2 questions or 3 questions. And of course, needless to say, your email and your mobile numbers are completely confidential. Currently, I have no responses. So I think you guys are filling the form. So I'll just wait. We should get 13 responses in. Once you fill the feedback form, please say done in the chat box so we can see that one of you has just filled the feedback form. Raj has sent it. And how about the others? Please say done in the chat box once you fill it up. We'll just complete this step and continue on in our journey. What happens a lot of the times is we take the feedback form at the end of the class and a lot of the people have left and they don't receive the recording, the presentation, and the Excel sheet data that I just shared a short while ago. All of those will be shared with you. Okay, so we've got 2 feedbacks in. Thank you so much, Vismita and Raj, for completing your feedbacks and saying done in the chat box. How about everyone else? Okay, so we've got 6 feedbacks in now. Wonderful. right? Howard's done as well. And a couple of you also others have also filled in their feedback. I think it's just that you haven't said done in the chat box. So we're up to 6 now. 7. Okay, great. Just wait a little bit more. Thanks, Nikunj. 8, 9. Superb. I think your feedback's really valuable. It just helps us improve on and on. And we've got 10, 11. Oh, wonderful. Thanks, Gajender. 2 more. They're on their way. Thanks, Mohammed Iman. Okay, it's great. I think there's just 1 or 2 people who are just filling it up right now. And Fang Lee's done as well. Thanks, Fang. So 12. Oh, wonderful. Just 1 more. Okay, I'm sure that I have enough, and all of you will receive your recordings, the presentation, and the materials for today's class, and the data set as well, right? Right. So where did we leave it? Where we'd left was we learned about, and just a quick summary, right? We learned about the different types of analysis, unibind multivariate populations and samples. We learned about what is a representative sample. We also talked about numerical and categorical variables and the tests that you need to apply to make sure that you identify them correctly. And we finally spoke about random variables as well. What we need to learn now is mean, median, and mode. And exactly where are we in our journey? Apologies. So we've now reached, we've covered the first module. We're done. Superb. And now we're going to talk about descriptive statistics. Okay. I'll probably cover the measures of central tendency today and take it from spread onwards the next time. I'll introduce spread today and I'll go into the details in our next class. Okay. There we go. Okay. Mean, median, mode, or the measures of central tendency. You see, how many of you have heard the word that, the center of the crime syndicate is a person in a particular country? Or if you've heard the word the kingpin of the gang, right? Have you heard of these words, the kingpin or the center of the crime? In the newspapers, have you read about, these kind of words? What are they trying to say, right? What they're trying to say is that, well, you know what? There's a lot of people that are involved in this crime globally, for example, drug trafficking. But at the center of all of these people is one person, okay, somewhere at the center of all of this, who is running the whole show, right? And they always want to identify and eliminate that one person because they know if they do this, then to a large extent the entire syndicate will be impacted, right? They want to reach the mind or the brain, isn't it? Right? The head of the gang, absolutely. The head of the organization, says Howard. So you know what happens is whenever we have a lot of data, right, a lot of observations, our minds are confused, okay? And we're always trying to figure out, well, I see all of these, data points, but is there any one number that can describe all of these numbers? Is there any one observation that can help me understand all of these observations? And that's why we look for a measure of a central tendency. It is that one observation, okay, and I'm just going to put this here, that one observation that summarizes, okay, all the observations. Okay, there you go. So you know what it does? It just makes it simple for us to understand the data. But in order to do this, there are 3 different ways in which we summarize or look at the central tendency of our data. Okay, and let me talk about central tendency. The ways we do this are mean, median, and mode. All right. Let's start with one that's fairly easy. Let's start with the median. Okay. So I'm going to just rub everything off. Tell me, how many of you have read an article that says a motorcyclist, fell and his head hit the median and he got injured critically because he was not wearing a helmet, right? And when you hear that word, his head hit the median, the simplest way of understanding the median is it is the center of the data. Okay, so let's understand how that works. Let's look at a highway. Here we go. Now, let's just take any highway, okay? For example, let's take this highway over here. There we go. Yeah. I'm just going to copy this image here and paste it over here and ask you a couple of questions. Can you tell me that you see something right in the middle which is red in color? What do we call this? Anyone? I'm just going to mark this red color. What do you call this concrete in the middle of the road? What's the English word for it? It is called the median, the divider, and also called the median. And that's where the word median comes from. The barrier or the divider is nothing but the median. Okay, that's the technical word for it. Now, how many lanes do you see on the left-hand side of the barrier or the divider or the median? Can someone answer that, please? How many lanes? Fantastic. Okay, so we see two lanes on the left-hand side, lane number 1 and lane number 2, right? What we have here is not a lane. This is just, some extra space in case you need to park, right? Okay. How many lanes do you see on the right-hand side of the median? Great. Good, right? So you all see two lanes on the right-hand side too. So what is the median? A simple concept, right? The median is that line which divides the road into two equal parts. Okay, there you go. And there we've solved it. So I'll just put this down here on, two equal parts. Now, how do you measure two equal parts? Because there's two lanes on either side. Okay, so what is a median? A median is that point which divides the data set into an equal number of observations on both sides. Okay, an equal number of observations on both sides. All right, so if we're clear so far, let's actually rub off everything I've got on the board, and I'm going to ask you to identify the median. Okay, give me a second here, and I'm going to put some numbers on the board for you, and your task is to identify the median. The numbers are 6, 5, 9, 7, 3. There is one number in these numbers that has an equal number of numbers less than it and an equal number of numbers more than it. And which number am I talking about? Okay. And some people say 9, okay? Some people say 5, some people say 6, all right? So now, if you look at it, as a road, you'd probably say 9. But when you have numbers, what you need to do is arrange them in the right order to make sure you have, the right number of, let's maximize this here. So all you need to do is arrange them in the right order. I'll use a different color this time. Okay. So the smallest number here is clearly 3, followed by 5, and then 6, and then 7, and then 9. Now can you tell me which number has an equal number of numbers that are less than it and an equal number of numbers that are more than it? Which number am I talking about? Okay, And this time it's fairly easy. The number is 6, and you have understood what is a median. It is that number or that observation which has an equal number of observations less than it and an equal number of observations more than it. In this case, 6 has 2 observations less than it, 2 observations more than it. I'm just going to complicate this a little bit. Suppose the numbers were only 6, 5, 9, and 7. So let's say for a quick second here, let's say we had only these numbers 6, 5, 9, 7. And then which one would be the median? Oh, I'm stuck now. I'm stuck because, you know, I could say, well, 5, I could say 6, I could say 7, I could say 9, but I cannot pick any one of these numbers, okay? I'd like to pick 6, but I can't because, you know, there's one observation less than it and there's two observations that are more than it, okay? I'd like to pick 7, but the same problem. So in these cases, could someone tell me what might be a way to solve this? Okay, so, you know, Joanne has the answer there, and Joanne, you're absolutely right. In these cases, what we do is we know that this is the median, but there's nothing here, right? So what we do is we add 6 plus 7 and divide it by 2, and 6 plus 7 is 13, and 13 divided by 2 is 6.5. And so the median in this case is 6.5. Can we all please clap for Joanne? Yeah? And we're clapping for Raj as well. We're clapping for some of the others. Fantastic, fantastic. Okay, we'll move on very quickly. See, one of the ways of measuring central tendency of data is the median. The other very common way of measuring the central tendency of data is the mean. Now the mean here, let's take an example. If we had sales of 20 articles on Monday, 10 on Tuesday, and 3 on Thursday, 30 on Thursday, 40 on Friday, let's say. So Monday, Tuesday, Wednesday, Thursday, okay. Thursday is 40, and let's say Friday is 20 again, okay. What's the average number of items that we sold on all of these days? So for the whole week, we want to summarize this week for ourselves, and we know how many we sold on Monday, Tuesday, Wednesday, Thursday, and Friday. So what's the average number of articles that I sold? Anyone? Okay, so I have an answer. It says 24. So, you could quickly calculate 40 plus 20, 60, 70, 80, 90, 100, 120. So 120 is the total number of articles sold divided by the total number of observations, which are 5. And so the average would be 24, right? So excellent answer there. Now, this is the average, but you know where the average can go wrong? Suppose what happened on Friday was there was a huge demand and I ended up with 120 items sold. Now, this is not very likely to happen, but it just happened on that particular Friday. So as things turn out now, is that, when you do your totals, you discover it's 220 articles sold that week, all right? And divided by 5, okay? And as that turns out, that's going to be a much larger number, isn't it? So it's going to be 4, first of all, and 5. So it would look like that particular week I sold 45, while all other weeks I sell 24. So you all see the problem with the average, isn't it? You've got to be careful with the average because sometimes it can get skewed. I'm using a word skew. Now, what I mean by skew is it can get pulled in a particular direction, either on the left or on the right. So suppose instead of 120, and let me just change this even further, I only managed to sell on Friday 2 articles, right? And that would have made a the average again skewed, but instead of the left, it would have been skewed on the right. And we'll learn about these things in a short while. So another way to look at the center of the data is average or the mean. Okay, so we've learned the median and we've also learned the mean. And thanks, Raj, for the formula. Thanks, Mohammed Imran. And now we'll talk about the mode. This one should be very easy. Let's say, if you look at the average number of cars in households in Plano, Texas, and you survey 8 households, and in those households, you discover that one of the houses had 2 cars, the other had 4, 2, 3, 5, and then 2 cars again, and then 3 cars, right? So you surveyed 8 homes in Plano, Texas, just 8 homes, okay? And in those 8 homes, you found, well, 2 cars, 4 cars, 2 cars, 3 cars, 5 cars, two, two, three. There's no point, adding all of these and saying, well, the average number of cars is, 2 plus 4. It's a decimal, right? There's no point having a decimal. But you can see here, most people have how many cars? So if I use the word, most people that you noticed in Plano, Texas, had how many cars? Most households had 2 cars, right? And this is the mode. When one number occurs many times and it seems to be the norm, it seems, and I'm using the word norm, you'll get used to these words, or normal, to have 2 cars in Plano, Texas. A lot of people seem to have it. Okay, and even the others, well, if you look at the mean of all of this, okay, so if you look at the mathematical average, 2, 4, 6, 2, 8, 3, 11, 6, 17, 18, 19, 20, 21, 22, 23, 24, and 24 divided by 8 observations is equal to 3. So the average is 3 cars, but it's getting pulled in that direction because of this 5. The reality is a lot of people have 2 cars. So you now know that we've got to look at all the measures of central tendency and not just one of them alone to understand the center of the data. And we'll come to skew later, right? But let's talk about an application of mean, median, and mode, right? Applying things is really important. And we'll stop after that for today, right? So I'm going to take you to, a hot topic. Everyone wants to know before they enroll for a college, how much money are they making in the college? I mean, it doesn't matter if the college is MIT, and there you go, the Massachusetts Institute of Technology, wonderful college. Or if it's in India, let's say it's IIT, and I'll pick IIT Bombay for a quick second. Also a wonderful college. A lot of people from IIT end up at MIT. There you go. Now, typically when you join these, colleges, you'd love to know that for your investment, what are you going to get in terms of a return, right? And it's easy to see how much money you're going to invest. Here's the tuition per semester. Here's the other fees and all of that, right? The annual fees and total fees and all of those things. But how much am I likely to make when I pass out of these colleges? This is where a lot of people use the mean and they say, oh, okay, everyone, knows the average. So instead of mean, everyone just says the average, salary at IIT Bombay. Okay. And the moment you say average salary IIT Bombay, Google gives you some results, right? And right away, Google says 11.32 lakhs. And for those of you who are not aware, I mean, lakh is nothing but 1 grand. 1 grand is $100,000. Does everyone know a grand? Okay. So how much is this? This works out to, if you look at the number, it's 11,32,000. That's 11.32 grand. Okay. Or it's in slang language, or 11.32 lakh rupees in Indian, language. Okay, there you go. So that looks like a lot of money, if you ask me. Okay, it looks like this is pretty good. I think I want to join this college, but the reality is that this might not be the best measure of central tendency. When I look at salaries at a college like MIT or IIT, I might not want to look at the mean salary. Why do you think I say so? Why do you think it may be a bad idea to look at the mean salary? It has something to do with some very big companies and the kind of behavior that they show when they come to a college. which is an Ivy League college. Anyone? Okay, let me ask you this. Do you think Facebook is likely to give a very huge salary when it comes to this college just to make a statement? Yeah. Do you think Google is also likely to match Facebook and throw out a really big salary? Yes or no, guys, girls, everyone? And what's that going to do to the average? Jyoti, Joanne, what's that going to do to the average? Puga? It's going to skew the average. It's going to make it look bigger than it really is. Let's find out if this is true. You see, if the mean skews the average, then the mean is going to be greater than the median. Okay, what's the median? The median is that salary where 50% of the students earn less than that number and 50% of the students earn more than that salary. I'm really curious what the median salary is. Let's find out. So if I join IIT, will I make 11.32 grand or not? Well, if half the people make 11.32 grand, I do too. Let's find out. So instead of average salary, can you please Google, and you can try this on your computers, the median salary at IIT Bombay. And now when you do this, it still shows you the outcome of the average salary on top. So Google still gives you this number because this is the number that has a lot of publicity. But this is not what we're looking for. So go down below, right, and search. Let me go down below and see if I can find that number there. There you go. You'll find an interesting article that says at IITs, the median offers are more modest than the mean offers. And you will see a small number here that no one wants to see. It is not 11.32 grand. Okay. Can someone tell me how much it is? Can you see this, or shall I make the screen bigger? Can someone see this number here? Come on, folks. Absolutely. It is 8.5 lakhs or only 8.5 grand. Do you guys see the difference between these two numbers? So do you see that if you Googled in a hurry and you used the wrong measure of central tendency, you might have thought that you'll be a millionaire in terms of Indian rupees, but the reality is that you might only make 850,000. Okay, 8.5 grand. You're not going to be a millionaire. There you go. So your hopes are dashed, aren't they? Okay, it's still a great college, but I think you all get the point. It's very important to choose the right measure of central tendency for the right data. And choosing the right measure of central tendency is critical. Can someone tell me now in what kind of college do you think it might be a good idea to look at the mode salary? We all know the mean and the average, but sometimes it might be a good idea, a really good idea to look at the mode salary. Can anyone try that in the chat box? Okay, let me give you a scenario. Let's say there's a very small college, all right? Really small college. It's also in a very remote region, okay? But there's some good news, right? The director of the college, right, the dean of the college, happens to know the CEO of another company, and that company, let's say, recruits a lot of people. So it's a bulk recruiter. It recruits hundreds of students. It's into BPO, for example. Let's say it's a BPO company. Now, the dean invites his friend, the CEO, over to the campus, and his friend, the CEO, says yes, and he comes to the campus, and they end up recruiting 80 students, out of 115 students in the batch. So just about the whole college got recruited by this one company, and this one company is known as a bulk recruiter, right? We call it a bulk recruiter. All of them got 6.5 lakhs, right? But a couple of other companies came and made some huge offers. So the mean and the median are different, okay? But everyone, almost all of them, 80 people got 6.5 lakhs, 6.5 grand, right? The mode is 6.5, isn't it? And don't you think in this college, given the chances of recruitment in this college into different companies, don't you think there's a pretty significant chance that next year, and that's why I keep talking about probability or chance, right? Don't you think there's a pretty significant chance that next year I may end up in this college getting recruited by the same company, right? And the same company may make me the same offer 6.5. So don't you think that 6.5 is a great measure of central tendency for this data? Yeah? Okay. Yes or no? All right. Absolutely, right? So you all know now it's not just about the mean, median, or the mode. It's also about understanding where to apply which measure of central tendency. And sure, we'll show you how to do this in R programming. We'll show you how to do this in Excel and all of that. But I think, the concept, guys, the concept is far more important than the tool. And very often I see that people get stuck in the tool. They also get stuck in the syntax, so they're obsessed with Python and they're obsessed with the libraries and all of that. But I think the concept is very important to master before you reach the tool. In the next class, we will then learn about a few more things. Where have we reached so far? Let's just take quick stock of where we've reached so far. Okay. So we've actually covered measures of central tendency, data variables, types of variables, population sample, and types of data analysis. And now we need to move to the spread of the data in summarization and visualization tools. Okay, this we will do in our next class, but I will show you just so you can actually start reading about this and understand this a little bit better. We'll calculate the mean median mode next time in R as well as in Excel. And we'll learn to use the data analysis tool pack added in Excel. It's a wonderful tool pack, right? In fact, I could show you today if you hang around. We will then talk about how much the data is spread out. And see, as you can see here in this particular case, right? You'll notice that the red data is not as spread out, okay? It's less spread out than the blue data. This is actually more spread out. And what implications does this have on analytics is something important to understand. There's 4 concepts that we will understand in our next class. We'll understand the range, the standard deviation, the variance of data, and the interquartile range. And then we will move ahead and learn about certain summarization and visualization tools in R. And we'll talk about the scatter plots. So this particular scatter plot has been put together in R. We'll learn to do this next time. We'll talk about histograms. We'll talk about box plots and what they convey and the definition of an outlier using box plots, right? So these are some of the things that we'll cover next time. We'll also learn about the probability distribution functions in our next class. And then we'll stop there because after that we need to go for important topics like hypothesis testing and then begin predictive analytics, which is linear regression. Okay, there we go. So I do hope all of you enjoyed the class. You will get the recording very soon. I hope to have it across to you in a pretty short while. I think we need around 3 or 4 hours to just convert the recording and upload it and share it across to all of you. Thank you so much. You will receive the presentation, recording, and data. Okay, and the next session is next week. Jyoti, yes, absolutely. So I'll be giving you some time. There's one assignment that I have for you all today. Okay, when you receive this data, and tomorrow I want you to, do this assignment, and I'm recording this right now at this point in time. I had shown you certain important relationships, right? So I inserted a pivot and I played around and I understood the relationship, for example, between miles per gallon and origin. But there are many more hidden relationships in this data. Just like you saw, the different origins led to different miles per gallon. If you actually analyze this data, you'll see there's a relationship between the weight of the car and the acceleration. You'll see there's a relationship between the number of cylinders and power, right? Horsepower, okay? And this varies a lot. If you add origin, it'll get even more interesting. So your assignment is to spend 1 hour on this data and try to pull out all of the following things, okay? I want you to pull out all the information you can extract that's meaningful, any knowledge such as horsepower being inversely proportional to, the cylinders, any other, let's not get to predictions at this point. Let's stick to, knowledge and information that you can gain from this data about cars from these different countries. Okay, but I want you to spend 1 hour in the world of analytics. We call it date the data. So I know what we all mean by date, but I want you to date the data and spend 1 hour with the data. I need you to give me any two observations, insight, knowledge that you gained from this data. Okay. And also, I want you to Google, and this is your assignment for tomorrow. I want you to Google things you don't understand, like engine displacement. So when you understand engine displacement by Googling it, you will gain what we call domain knowledge. So apart from all of this, it's really important to understand the domain of cars. Okay, so all of these variables, I want you to Google them. I want you to understand the domain, right? There you go. Now, once you're done, I will personally look at your assignments, and I will, Raj, Shikhar, Buga, I will look at your assignments. I will personally mark all of your assignments. Okay. Where do you need to send all of this to me? You need to send this to me at my email ID, contact@EquiSkill.com. And don't worry, I'll mail you, but I'm just sending it here in the chat box. And those of you who missed the first session, I will also send you the recording of the first session along with the second one. Okay. So I got that, and in the email, I'll send you the first session recording. Okay. All right, so let me just check right away if you give me a second here. Okay, are you guys all clear on your assignment for tomorrow? You're going to understand and read about cars, understand and read all the variables, and send me any 2 or 3 insights. You're going to spend 1 hour on this data. You're going to date this data, right? Superb. At this point, I'm going to say thank you and officially end the class here at this point in time. So I'll stop the recording. Thank you so much, and please do expect the recording very shortly. Okay, a lot of you have already joined the course. Some of you are just about to join the Analytics Accelerator certification. So thank you all and see you all next week.